All right, picking up in the second half of the video for today, we're going to talk about the sum and difference of two cubes. This is a type of factoring that you have not seen before in Algebra 1, so this is like new to Algebra 2. But there is a special formula here that you can follow. So if you have the sum, which refers to addition, or the difference, which refers to subtraction, of two cubes, okay? This is kind of like the difference of two squares, right? But this applies for the sum or difference of two cubes. So if you have a cubed plus b cubed, that would factor into a squared, b squared. And you're going to hear us say that all the time, okay? Regardless, if you're doing subtraction, same thing. A squared, b squared. The difference here is in your signs. And we keep our signs in order by remembering to use SOAP. SOAP stands for same, opposite, always, positive. So the sign here from your original stays the same, and then it's the opposite, and then the last one is always positive. Same thing here. Same, opposite, always positive. So the big question that comes up is, Money, where do you get like the A and the B? Like, where do those come from? The A and the B come from the cube roots of what you are given. So your cube roots, we probably need to make a list. 1 cubed is 1. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I think that's all I'm going to require y'all to know. So, knowing those perfect cubes, let's take a look at B. We have 8x cubed plus 27. So, in order to use my formula, I'm going to write a squared, b squared. And then let's use our SOAP to figure out our signs. This would be the same as the original, opposite, and always positive. So my next step is to figure out what my a and b values are. The cube root of 8x cubed would be 2x. The cube root of 8 is 2. The cube root of x cubed is x. For my b value, I would take the cube root of 27, which is 3. So now I'm going to take those values and plug them into my formula. I would have 2x plus 3. Now for the a squared, I'm going to square my a term. So that would be 4x squared minus a times b would give me 6x. And then plus my b value squared, which would be 9. And that is the factored form. I know what you're thinking. Are we going to solve these? Yes, we're doing that on the next slide. But we need to make sure that you know how to factor them first. So on part C, same thing. We notice that's the difference of two cubes. So we're going to use our formula, a squared, b squared. And my signs are the same, opposite, always positive. So let's figure out what our a and b are here. A would be the cube root of 64x cubed, which is 4x. B would be the cube root of 125, which is 5. So here I go, plugging in. I would have 4x minus 5 times a squared. That would give me 16x squared plus 20x plus 25. 25 came from the 5 squared. And so now we know how to factor the difference or the sum of two perfect cubes. So now let's throw in the solving portion. So here it says, what are the real or imaginary solutions of each polynomial equation? X cubed equals 27. You're still going to approach this just like we did the opening problems. We have x cubed minus 27 is equal to 0. And we notice that that's the difference of two cubes. So we're going to use our formula. A squared, AB, B squared. And A and B are going to equal X and 3. And don't forget your signs like I just did. So same, opposite, always positive. So from here, we're going to say that's X minus 3 times X squared plus 3X plus 9 is equal to 0. Now this looks just like what we did at the beginning. I'm going to set both of these individually equal to 0, and I'm going to solve. So I would have X minus 3 is equal to 0, so that means X equals 3. And then, is there something that multiplies to give me 9, adds to give me 3? No, so what am I going to do with this equation? I'm going to have to do the quadratic formula. So X equals negative B plus or minus square root of B squared minus 4 times A times C all over 2A. So we get X is equal to negative 3 plus or minus the square root of 9 minus 36, which is negative 27, all over 2. The square root of negative 27 breaks down. The square root of 27 breaks down into 9 times 3, so that gives me 3 radical 3, and there's a negative under there, so that means I have to take the I out, and everything is over 2. I'll just give you a rule of thumb here when it comes to these cubic, the sum or difference of two cubes. Your majority of the time, if not every time, you're going to have one real solution and then you're going to have two imaginary solutions. Okay. On this next problem down here at the bottom, we have the same question, and you'll notice here you have 2x cubed is equal to negative 54. So let's set the equation equal to 0. Oh, oops. And you'll notice, like, you have the x cubed and you have a constant, but they're both not perfect squares, or perfect cubes. So what can you do? Well, you're going to do what we did at the very beginning. You can set it equal to 0 and then see if you can factor. You could take a 2 out, and that leaves you with x cubed plus 27. Right? So now by taking that GCF out, you have revealed the difference, or the sum here, of two cubes. Okay? So, would you set the 2 equal to 0? No. You would only focus on the x cubed plus 27 is equal to 0. So from there, you would be able to solve just like we've been doing. So real quick, if you want to practice, that would be A, B, A squared, AB, B squared. It's the exact same as above, right? I didn't have to do any extra work to find my A and my B. However, my signs are different now. Same, opposite, always positive. So you would have x is equal to negative 3 as one of your solutions, and then you would need to do the quadratic formula to find your other two solutions. For the sake of time, I'm not going to do that because we're going to move on towards the application piece. But if you have any other questions, you can ask us about the quadratic formula anytime. But let's talk about graphing, okay? How do you find the real roots by graphing? All you have to do is what you've done before. Set the equation equal to 0, get it in y equals. So here we're going to say x cubed plus x squared minus x plus 1 is equal to 0. And I'm going to type this polynomial into y equals. So grab your calculator, and we're going to clear out what we got there. And we're going to say x cubed plus x squared minus x plus 1, and we're going to hit graph. So as we learned back in the 5.2 lesson, it looks as if it's only crossing the x-axis one time. So we're going to find that one real solution by doing second trace 0. So we're going to go to the left of where it's crossing the x-axis. we're going to go to the right of where it's crossing the x-axis. And then if you want to take a guess, you can. And one of your real solutions is negative 1.839287. Now, I know what you're thinking. The fundamental theorem of algebra says you have 3 solutions, right? But we only saw where it crossed the x-axis one time. We saw that it was at negative 1.83 something 9, I don't know, right? What does that mean for the other 2 solutions? That means the other 2 solutions are imaginary because we did not see them cross the x-axis. Well, what do we know about imaginary solutions? They come in pairs. We will never have an odd number of imaginary solutions. So, for example, if the fundamental theorem of algebra says I can have 3 solutions, right? Your scenarios break down into all 3 being real, or you would have 1 real with 2 imaginary. Could you have 2 real and 1 imaginary? No, because imaginary solutions come in pairs. And this ties in with the 5.6 fundamental theorem of algebra worksheet. Okay, so all you have to do is find where it crosses the x-axis. Same thing with this problem here. We got to get it equal to 0 first. So we have x cubed minus 4x squared minus 7x plus 10 is equal to 0. I'm going to grab my calculator, and we're going to type that into y equals x cubed minus 4x squared minus 7x plus 10, and then we're going to graph it. And so we can see here, this was x cubed. It crosses the x-axis clearly 3 times. So we have all 3. And we can find them by doing second trace 0. But they look like they cross through the x-axis like really perfectly. So we can go to second graph and look at the table and see where it crosses the x-axis. So one of our solutions would be negative 2. The other one would be 1. And the last one would be 5. Now, this strategy for solving polynomials by graphing comes in handy for our application. And we're going to finish our application in the last part of the video.